welcome to Lesson 8 of Chapter 3 of Probability and Statistics. Today, we're just going to put it all together. We're taking real-life z-scores and percentages. So our essential outcome for today is that you'll be able to translate between observations and percentages. So remember, sometimes we're given an x value, sometimes we're given the z-score, and sometimes we're given the percentile, and we can find any of these values. We just have to know the right formulas to use. So, horse pregnancies are normally distributed with a mean of 336 and a standard deviation of 3 days. So your mean would be 336, so you're going to have 339, and you're going to have 333. And I'm not going to fill in the rest of the table, but that's what we've got. So, our first question says, what percentage of horse pregnancies are shorter than 334 days? So remember that z-score formula. Z equals x minus x bar over sx. That gets us our z-score. And so if we want to find out what percent of horse pregnancies are shorter than this, we need to first find the z-score. So we can plug in these values that we know. Our x is 334, our x bar is 336, and our sx is 3. So if we do that, we get negative 0.66. And so now we go to our standard normal distribution curve. We find negative 0.6 on the y-axis. We go over to 0.06, and we get 0.2546, which is 25.46% of horse pregnancies last shorter than 334 days. Not too bad. So here is our next question. It says, how about if they're longer than 341 days? So we use that same formula. This time, though, instead of 334, we're going to use 341. We go 341 minus 336 divided by 3. And we get 1.66. So we find that on our standard distribution table, 1.66. We get 0.9515. But remember, it said it's longer than 341 days. So this is going to be somewhere around here. And that 0.9515 is it's what's less than. So we go 1 minus 0.9515 to find the percent that's longer. And we get 0.0485, so 4.85%. So now they want to know how about horse pregnancies that are between 335 and 339 days. And when we did this last time, remember we had to do this for each one. We had to find the probability and we subtract them. So we have to set up our equation for each one. We go 335 minus, well, our mean was 336. Divide that by 3. We needed to do the same thing with 339. We get negative 0.33 for that first one. We get 1.00 for this one. Let's find those probabilities. Negative 0.33 is 0.3707. 1.00 is 0.8413, and then we take the bigger probability, 0.8413, and we subtract the smaller probability. And we get 0.4706 or 47%, 47.06%. And so the next question they ask is the 40th percentile of horse pregnancies is. So now we have to remember how to go back from a percentile to the. When we're given the percentile, we go back to our table and we change this percent to a decimal. So we go 0.400. or 0.4000. And we look for that in the middle of the table, or whatever we can find that's closest to it. Alright. And it looks like the closest I could find to it was 0.4013, and that has a z-score of a negative 0.25. And so what we do now is we know the z-score, but we don't know how many days this is. So we go back to our equation, our z equals x minus x bar over sx. We plug in what we know. We know the z-score is negative 0.25. We know the x bar is 336 and the standard deviation is 3, but we don't know how many days it is. So our goal is to find x. So we do everything we can to find x. We multiply both sides by 3. Get negative 0.75 equals x minus 336. We add 336 to both sides. 336 plus negative 0.75. This gives us that x equals 335.2.